Hello guys, this is the last video of our 6th unit where we will be finding the mean and variance of Poisson distribution using PGF. So mean and variance of Poisson distribution using probability generating function. So let me write. Probability generating function is defined by gx of t, which is expected value of t power x. Now we have to do for the Poisson distribution, right? So sigma x is equal to 0 to infinity t power x into p of x is nothing but sigma e power minus lambda into lambda power x by x factorial. That is, if powers are equal, we have to merge the base values. That is sigma x equal to 0 to infinity t into lambda power x into e power minus lambda by x factorial. That is, so we all know that z power x by x factorial is equal to e power z. So here e power minus lambda into e power t lambda. So we can also get it as e power lambda. If we take lambda as common, we'll be getting if we take lambda t minus 1, it will be remaining. That is gx of t. Okay, now let us find the raw moments. That is mu1 dash is equal to mean, that is d by dt of gx of t such that t equal to 1. So d by dt of, what is gx of t? Nothing but this equation, that is e power minus lambda into e power t lambda such that t equal to 1. So what is the constant term? E power minus lambda is the constant term, so we'll be getting outside, take it outside. So d by dt of e power t lambda such that t equal to 1. So differentiate with respect to t, so we'll be getting e power minus lambda into e power t lambda into lambda such that t equal to 1. Now substitute t equal to 1 in the equation, we'll be getting e power minus lambda into, what is e power t? E power t means e power lambda into lambda. We know that e power minus lambda, e power lambda will be getting cancelled and we'll be having a lambda, that is mu1 dash is equal to lambda. So now let us find for the variance. So variance is equal to double derivation, that is equal to d square g x of t by dt square such that t equal to 1. What is d by dt of d by dt gx of t such that t equal to 1. So d by dt, what's the equation? So this is the first order derivative, that is d by dt of e power minus lambda into e power t lambda into lambda such that t equal to 1. So what are the constant terms? E power minus lambda and lambda are constant terms, so get it outside. E power minus lambda into lambda, and we get outside, what's the remaining term? So d by dt of e power t lambda, you have to differentiate with respect to t equal to 1. So e power minus lambda into lambda, what will happen if we with respect to t? Will be getting e power t lambda into lambda such that t equal to 1. Now substitute t equal to 1 in this equation, we will be getting e power minus lambda into lambda. What will happen? We will be getting e power lambda into lambda. So e power minus lambda will be getting cancelled and we will be getting a lambda square, lambda into lambda square. But I have already told in the previous video that for the mu2 dash, we have to in probability generating function, we have to add the e power x value into x value or mu1 dash value to it, so that we'll be getting a resultant value. So if you remember this step, then we have to add mu2 dash equal to lambda square plus lambda. So this is our resultant mu2 dash. So to find the variance, what is the process next? What's the next process? Variance is equal to mu2 dash minus mu1 dash whole square, right? So what is mu2 dash? Mu2 dash is lambda square plus lambda minus mu1 dash is lambda square. So lambda square minus lambda square will be getting cancelled and we'll be getting a solution of lambda, that is variance. So variance is equal to lambda. Therefore mu1 dash equal to mu2 dash is equal to lambda. So this is the actual process to find the mean and variance in a Poisson distribution using PGF, probability generating function. So this is a step. So let us wind up this sum. gx of t is equal to e power t power x. Expected value of t power x is the pgf. Then later we have expanded and found the pgf equation with respect to Poisson distribution. Then we went on with the finding the raw moments, that is mean. So in mean we have find that mu1 dash is equal to lambda, because then we went to the variance. So mu2 dash is equal to double derivation of a probable generating function. Then we have tried to derive the entire sum. Then we got mu2 dash is equal to lambda square, but we know that mu2 lambda is equal nothing, is not the correct answer. Then we went on adding the expected value of mu2 dash. Then we find the variance. Then we calculate the variance, that is mu2 dash minus mu1 dash whole square, that is lambda square plus lambda minus lambda whole square. We'll be getting lambda will be lambda square will be getting cancelled, and variance is equal to lambda. So mu1 dash is equal to mu2 dash is equal to lambda. So small this is the actual process to find the probability distribution using PGF. So let me explain the what we have done in the 6 units so far. 6 units is nothing. We just have to generate the functions of binomial and Poisson distributions. So just to follow the basic structure that we have to substitute in the so let me take another note. This conclusion. So what is the conclusion? I will give the structure, so don't worry. Structure is nothing but if they give that mgf or characteristic function or probability generating function, or what is the another one, or cumulant generating function, just try to substitute the binomial. We have to only do for binomial and Poisson distribution only. So in exam, if they ask about the binomial Poisson distribution, so I will give you the structure that substitute binomial B or Poisson distribution in the four generating functions. And get an equation. So get an equation. So after getting the equation, what we have to find the mean. So mean is nothing but the mu1 dash is nothing but the first order derivative of d by dt or d by dx of these four terms, four generating functions. So this equation, four generating function equation. So we will be getting a mu1 dash value. So after mu1 dash value, we have to find the variance. So how we should find the variance? Mu2 dash is equal to double derivative d square of 4 into generating function equation by dt square. So this is the then we will be finding mu2 square, right? So this is the actual process to find any distributions. So just simple, just remember, if you in case if you don't get answer in the examination, for binomial mu1 dash is nothing but the np, mu2 dash is equal to npq. In Poisson, mu1 dash is equal to lambda, mu2 dash is equal to lambda. So these are the two we need to find for all the equation. So in exam, if you get stuck in any of the step, just try to elaborate the each and every step, and last make a note of mu1 dash is equal to np and mu2 dash is equal to npq in binomial, and mu1 dash is equal to lambda and mu2 dash is equal to lambda in the Poisson distribution. That will be fine, because because we have to get the answer as np or npq or in lambda. So that is the answer we required. So the remaining step, it doesn't worry, but we have to follow the basic structure. So hope the conclusion steps are clear to you, and the int also is clear to you. Hope you enjoy for the meet. Thank you.